Hey, so here's the garage light all finished up. He's actually not a garage light lately. He's filling in for some of my smaller LEDs for my indoor grow. As soon as he's done for the day, we'll have a look at him. So here's a look at the business end of the light here. So I've got the cobs all basically glued down with thermal epoxy there, so I don't have any holders or anything like that. And they're in parallel, so you have negative to negative, and then positive to not positive. So it's two parallel, they're all in parallel. So two parallel there, two in there, two there. So we've got 8 total chips there. And then so what I have here is, you know, the power in coming to this positive, and then the negative going out. And then this is Kapton high temperature tape, and that works pretty well for holding wires down. This thing doesn't get very hot at all though. There's the switch. Let's turn it over. Oh, one thing I'm doing wrong, or suboptimally anyway, is paralleling these cobs. Generally you'll want to series them because that's parallel, because I'm running 300 milliamps to each group, right? So so they should share that equally, right? You would hope. So 150 milliamps each cob. Well, if one gets hotter than the other, if you check out thermal runaway on Google, so if one cob gets hotter, it'll draw more current, and you could end up, you know, soaking up way more current than, so more of the 300 milliamps than this one. And that's not good. So what you can do is use really well matched LEDs, which these are according to the data sheet, which we'll go have a ponder at next. According to the data sheet, that these are like, difference would be like 7% max, because Cree bends them or sorts them based on different power and color characteristics. And so that's one thing you can do to keep them sharing current equally or more equally. And another thing is just to keep them the same temperature, right? So we have them on the same heat sink. This is a 6-inch heat sink, and so that's the one thing I did wrong. The second thing, while we're at it, is I used just a voltage booster, right? So we're not current controlled, and so that with thermal runaway you could you know, burn up your chips. But I found with this particular I found running it low, which I believe is 600 milliamps. These can handle 600 milliamps. We're doing 150, so you know, a quarter of what it's rated for. If you run it low and then keep it cool, don't have that problem. But generally, use a current limited device. Let's check out the data sheet. Alright, so here's page 6 of the data sheet for this this chip. So it's a 36 volt, that there's also an 18 volt flavor, which would be nice, but it's not what I have. But so what I have is the 4K. This is color, so 5,000 Kelvin. What is that? 5,700 Kelvin, 6,500 Kelvin. So as you go higher, the bluer the light. And another thing you notice, this is lumens here. As you go bluer, you get more lumens. Although it doesn't look like that's the case if I go look at something like this. Anyway, so here's my chip. I have the N2, 4K N2. So if you keep it cool, we can expect, so at 25C we can expect 1739 lumens. And scrolling down, this is just kind of how I get an idea how much light I'll get. And then here's kind of a power. You can figure out your power. So we're doing 150 milliamps. Keep it cool. We can expect something like 33.5 volts. So right about 5 watts a chip. So that's kind of a piece I use. Okay, relative luminous flux. So here's kind of how I look at how much lumens at what kind of current, right? So we're doing lower than, oh, so this is the 18 volt. Let me find that 30 volt. There we go, 36 volt. Where's it at? Okay, there it is. So 150 milliamps, keep it cool, right? 25C, this blue line, about, call it 50%, right? So if we go back here, and 4K into, so 1739. So, you know, 870 lumens per chip, right? Thereabouts. And so that's roughly a 60 watt incandescent or a 13 watt CFL, you know, in the ballpark. We have 8 of those, so we're looking like 6,000 or 7,000 lumens. Not too shabby. And one last thing. The 36 volt chip. There's the voltage. Oh, here's the current. So max current 600 milliamps. So that's what I thought I remembered. So we're doing, you know, about a quarter of what it's rated for. Okay, just starting with the power in. This is from a Dell. I think it's a 95 watt. This is a 7.2 millimeter, 7 something, right? This is an adapter, 7 something in, 5.2 or 5 something out, right? So that's pretty much that. And that goes into this guy. Power goes in. I have a few, so I could put some more accessories on there, but this is a JST connector. I think, I can't remember what I did. 20 gauge into the switch that powers both the, there's a lot going on here, but it's pretty simple. So there's the switch on the, you know, the underside. And this is the fan driver, so that's taking just a simple buck converter, nice and cheap. That is just taking our 20 volts down to the 12, or I forgot what maybe 8 volts. And these are just 50 millimeter fans. These are called Sunon fans, and they're very awesome. I think it's a maglev bearing, special kind of bearing, and it's good stuff. They're really quiet and it sounds really cool, and which you'll hear in a minute. So here's the boosters doing all the boosting to 33 volts or so, and then I do have the JSTs. So each fan and each arm on the light is got its own connection. So if I wanted to, if I just wanted to run that light, I could disconnect, you know, 6 connections for the fans and the lights on the other arms, and I could do that, but that would be tedious, but you could do it. Alright, let's get a, let's dazzle the camera here. Ow. Okay. So they're pretty, I mean, a lot of times with parallel wiring, you'll have some cobs, you know, some lights will be brighter than others. You're probably not going to be able to tell very well in the camera, but they look pretty uniform. So here's the fixture up in the garage here. So I just took some climbing webbing, about 56 inches or so, and then it's just looped between the rapid links there up to 2 hooks there, and it's works all right. So here we go. I just need to string up the laptop power supply, and then I also did a second set of hooks on this side of the garage too. So I should have built 2 lights, but maybe I'll build another one. But so let's string up the power, and I have a switch up here, not a switch but an outlet. Let's string up the power, and then we'll See before and after. Before. After. Alright guys, thanks for watching, but stick around. Next up we have some projects with actual proper LED drivers. So stay tuned.